Everyone, you know very well that in previous video I explained about the natural magnet. Okay, about what? Natural magnet. Okay, so in natural magnet I discussed with you all different kind like that: horseshoe magnet, bar magnet, north pole, south pole, attraction, repulsion, why magnetic lines do not cross to each other. Many things I discussed in the previous video, but in this next topic I will discuss a different kind like that types of magnetic fields. Okay, types of magnetic fields. Number one, here is two kind of the magnetic field. Number one is the uniform magnetic field. Means, what do you understand by uniform? Uniform means what? Equally distributed. What? Equally distributed means we have different lines like that. These are the magnetic lines. Okay, so all these lines will be parallel to each other. You can see all lines are parallel to each other, and all lines have their only one direction. What? One direction. So we can say magnetic lines is said to be uniform if its magnitude is equal and direction is same at every point in space. Okay, if we have a magnet, like if we will get magnetic lines from this magnet, so those lines which will come from this magnet, these magnetic lines direction should be same, and at all places these magnetic lines equally distributed. Means it should be parallel to each other. What? Parallel to each other, right? Second thing I'm going to tell that non-uniform magnetic field. Non-uniform magnetic field. In the case of non-uniform means not equal. So we can say there, in the case of non-uniform magnetic field, initially magnetic field can be parallel or can be more difference between the magnetic lines. So we can say these magnetic lines will not be equally distributed, right? So at many places difference between them will be more, and different points the difference will be less. So we can say these lines will not be equally from all sides, and direction of all magnetic lines will be equal. Nothing will happen about it there, but simply one thing, the gap between the lines will not be equal. So all these lines will be what? Non-magnetic field. What? Non-magnetic field. Okay or not? Okay, any doubt? Okay. Next topic is there, very important topic. This is your syllabus topic. Above all these things I explained here, so these topics can be basic of the chapter. By all this topic you can understand the things, but here I am starting your syllabus. That first topic of your syllabus, that is the Oersted experiment. OERSTED, Oersted experiment. Right, this experiment is very important. Okay, it explained about the electromagnet. What? Electromagnet. Okay, what will you do in this experiment? You will select one wire. You will select what? One wire. It can be copper, aluminium, anything else. Okay, and for this experiment you need electrical wire, and you have to connect this wire with a battery. Okay or not? Okay, when you will connect this wire with battery, okay, we can say this is a wire and you are connecting this wire with the battery. When you will connect this wire with the battery, and in the circuit you will take one key also. One key will open and close the circuit totally. And you need what? A magnetic compass. So magnetic compass is helping for detecting the direction of magnetic field. When you will keep magnetic needle freely in our environment, what will you see? This needle aligned automatically in north and south direction only. In north and south direction only. So you can say that magnetic lines will tell us the magnetic field direction. What a magnetic field direction. Or I told you one day in the previous video, when you will supply electricity through a wire, so that wire behaves like a magnetic field. I told you means two kind of electricity. One was there na static electricity, and the second is what, dynamic electricity. Okay? In the case of static electricity, I told you that charge particle remains at rest. In dynamic electricity, charge particle will be in motion. Due to this motion of charge particle, we will get what, magnetic field. We will get what, magnetic field. I want to explain here one more thing also related to the topic. Listen, how we will get magnetic field. How we will get magnetic field. Listen here. Initially we have a wire. Initially we have a wire. Okay, so in this wire, you know, many numbers of electrons, and electrons means haven't any fixed shape, fixed direction, fixed direction. Okay or not? Okay, so initially it's not behaving like a magnetic field. Clear? But when you will connect this wire with electricity, what will happen to all these electrons after connecting with electricity? What will get one direction only. Means electrons start moving from one direction, means one point to another point. So we will get here what? One direction only. Or this one direction will help for making the wire behaving as an magnetic field. Due to this one directional electron will help. Okay or not? Okay. One thing, listen, I told you, in a magnet means inside we have two poles. One is the north pole, second is south pole. Means I told you that magnetic lines will come outside from north pole and enter in south pole. Okay, or magnetic lines move from north to south pole. I told or not? But inside, south to north. Okay or not? Okay, so we can say, the direction of here these lines, same like it. So here also the direction of electron only one, where electrons will coming out. So this part will become what? North pole. Or this part will become what? South pole. And outside circuit you can complete with yourself as same like it. Okay or not? Okay. So means in the case of wire, due to this one single alignment of electrons will create their magnetic field. Okay or not? Okay. Means same thing. If wire will remain at a point without electricity, so here is not a fixed direction of electrons. So this wire will not behave like a magnetic field. When you will connect this wire with electricity, then this wire behaves like a magnetic field. Okay or not? Okay. So this is a simple experiment explained by the Oersted. Okay or not? Okay. So same thing I'm telling here. One thing, listen. This is a wire. Till that you will not open the key. Here is two system. Close the key and open the key. When you will close the key, so electrons start moving through the wire. When you will open the key, electron, this time key is open. When you will close the key, so electrons start moving through this wire. Okay or not? Okay. So simply what will happen? This is what? This is our wire. Okay. You will connect it with the electricity. Okay. Or when you will connect this wire with electricity, electrons start moving. You are closing the key. Okay or not? Okay. When electrons start moving through the wire, so we can say this bigger terminal is positive or this bigger terminal is negative. Okay. Current start moving from positive terminal to negative terminal. In electricity chapter I explained everything. The current direction. Okay or not? Okay. Means current always moving from positive to negative terminal. That is the conventional current. Okay or not? Okay. Conventional current. We will not take here direction of electronic current. Okay. If this is conventional current, so electrons start moving through this wire. So all electrons will get their same direction. So I told in previous diagram that when electrons will get one direction only, so we can say there the electrons are moving in one direction. So this wire will behave like a magnet. And now for checking that magnetic field, what will we do? For finding the magnetic field value, we will keep magnetic needle near to it. We will keep magnetic needle near to it. Okay or not? Okay. So when we simply, I am just taking magnetic needle here. So we can say this is north pole or this is what? South pole. This is what? North pole or this is what? South pole. Or when I will keep magnetic needle along with it. When I will keep magnetic needle along with it, what will happen? Listen. Initially, if key is closed, now open. If initially key is open, so on that time no electricity into the wire, so magnetic needle will remain as same like it. Means you will keep north pole in which side, where electricity will come out through the wire. Okay or not? Okay, means near to it you will keep magnetic needle as same like it. Okay, in this side it will be north pole, or this will be the south pole. This is the fixed B. You have to keep in, you have to learn, you have to cram. Okay or not? Okay, from which side means electrons will come outside, so on that side you will keep north pole, and other side you will keep what? Will keep south pole. Okay or not? Okay, what will happen when electricity will pass through it? What will happen? This magnetic needle direction will change. It behaves as same like it, like it. Okay, this will be the north pole, or this will be the south pole. So we can say there, if you have a wire, simply if you have this wire, okay or not? Okay, if okay, I'm taking one more. You have this wire, and you are keeping magnetic needle as same like it. Listen here, this is magnetic needle. Okay or not? Okay, so we can say this is a north pole, or this is what? South pole. When you will pass electricity through it, so it will, its direction, how it will looking like that. Listen here, it behaves like it. So this is a north pole, or this is a north pole, or this is a south pole. So we can say there, north pole shifted inside direction and south pole shifted outside. Means before passing the electricity nothing was happening there, but after passing electricity we saw here that means this magnetic needle show deflection only, or magnetic needle shows deflection only when around it, near to it, any magnetic field present there or not. Okay or not? Okay, so we can say there, this wire behaving like a magnet, behaving like a magnet. Okay, if you will change the direction of the current, okay, listen how. Okay, we can see there, this is what? This is a wire. Okay or not? Okay, so simply you will connect this wire with what? Now I'm changing the direction, so you can see previous time, or you can see this diagram also. Now this is a positive terminal, this is a negative terminal. So in previous diagram, in this side positive terminal, in this side negative terminal. Okay, so simply this is what? Positive terminal, this is what? Negative terminal. Okay, in this case what will you do? If electricity will pass through this wire as same like it. Okay or not? Okay, so electron direction will be in this direction, means current will pass through it as same like it or not. So you will see only direction of the current only. What? Direction of the current only. Okay or not? Okay, on that time, if you are keeping magnetic needle as same like it, same thing you will keep here now, same thing you will take here. How you will take? 1 minute. So we can say in this side we were taking what? North pole, this is what? South pole. Okay or not? Okay, means ये तो I am keeping this magnetic needle means totally upside on it, but I am keeping here a little bit far away for showing means total clarification here. So see here, when I will pass electricity through it, then current will pass from this side to this side. Okay, now this time magnetic needle little bit moves upside, means magnetic needle becomes as same like it. This will be north pole, or this will be south pole. Okay or not? Okay, this diagram, if current will move as same like it from A point to B point, so in this side magnetic needle moves inside the wire, inside direction. Okay, if you will change direction of the current, so in this case this north pole will move upside. Okay or not? Okay, so this is the simple experiment. So this experiment shows that means around this wire magnetic field is present. Okay, then things I will explain here. I am just connecting things properly for learning. I'm telling for cramming the value. How will you learn? So simply we can say I'm just connecting things with east, west, north, south. Listen, how will you connect? We can say if we have this is east, west, upside is north, this is south. One thing, listen. First we have to keep in our mind snow rule. Snow rule. This rule is very important for learning. Listen, if current is moving from south to north, if current is moving from south to north, then magnetic needle deflection towards west. Okay, if current is moving from south to north, then magnetic needle deflection towards west side. Okay or not? Okay, if current moving from south to north, magnetic needle deflection where? In this side. So in the wire, in the case of wire, we can say if this is a wire, okay or not? Okay, so if you will connect, we can say this is north, this is south, or this is what? East, or this is what? West. Okay, then magnetic needle deflection will be as same like it. Okay or not? Okay, means this will be the magnetic needle deflection, or this will be the south pole. Okay or not? Okay, if you will take here simply this is what? As same like it, I can take here this can be the east, west, or this what? North, south. If current is moving in this side, current is moving from which side to which side? Snow means south to north, na? So deflection is where? West. If current is moving from north to south, then deflection will be towards east. Okay or not? Okay, towards what? East. Any doubt now? So this the simple thing you have to keep in your mind. So by Snow rule, you can learn the things. If current is moving through a wire from south direction to north direction, then deflection will be towards west direction. Okay, so this experiment explained by Oersted only. So he told that when through a wire we will pass electricity, then this wire behaves like a magnetic field, or this magnetic field explained by this value calculated observed by magnetic needle only. Clear? So we can include many points in this case. So all these points you can explain here by the help of strength of the magnetic field, anything else. One thing, listen, I'm including some points here. One thing, number one, when we will pass electricity through the wire, then this wire behaves like a magnet. Okay or not? Okay, second point also we can include here. If we will increase the value of current, means by increasing the value of current, the magnetic field value increase around the wire. Okay, number 3 point, by changing the current value, means first it will follow Snow rules. Means if current will pass through south to north, magnetic needle deflection of north pole towards west. If we will pass current north to south, the deflection will be towards east. So you have to keep in your mind both things. Only one thing you have to learn, other things automatically will connect with it. So these 3 points we observed there. So by passing electricity through a wire, this wire behaves like a magnetic field, or these points we can include for understanding the behaving of the electrical wire. Okay or not? Okay, like an magnetic field. So this topic related to the Oersted experiment. So here is the Ampere swimming rule. This point we can include in the case of Ampere swimming rule. When you will read it with yourself, you can understand automatically. Okay or not? Okay, I will explain related things next time. One experiment also I am including here related to it only, that simply what will we do in second experiment. One thing, this thing can be very important. How will you do? Simply what will you do? You will take a cardboard. What? Cardboard. Okay. Through the center of this cardboard, you will pass a wire. And you will connect this wire with the battery, anything else which can be electrical source. Clear? So we can say this terminal will be positive, this terminal will be negative. Okay, so you will spread on this cardboard some iron fillings. Iron fillings can be like that, iron powder, smallest pieces. You can break iron into the smallest pieces and you can spread on this cardboard completely, totally. Okay or not? Okay. And you know that means magnetic field. Your magnet always attract iron towards it. Attract or not? So you can include here same thing. So when you will spread iron fillings around it and you will connect key, when you will close the key, so what will happen? Current will pass through this wire, starting to pass through this wire now. So the direction of current is where? Positive, as same like it. Okay or not? Okay. So we can say when current will pass through this wire, positive to negative, when we will see there these iron fillings which are present around this wire, which are spreaded on this cardboard, so they will make here different circles like it. You can perform this experiment at your home also. So these iron fillings will spread around it in the form of concentric circle. Means we can say this can be the cardboard, this will be the wire which passes through the center. So these iron fillings convert itself in the form of different concentric circles. Okay or not? Okay. So we can understand here that means around the wires we are getting magnetic field, or this magnetic field will spread equally in all direction, which are making in proper alignment this iron fillings. Okay or not? Okay. Direction I will tell you later, means how we will get the direction of magnetic field in these concentric circles. Okay or not? Okay. So one thing of this experiment you have to keep in your mind, when we will pass electricity through this wire, so iron fillings arrange itself in the form of concentric circles. So we can say these concentric circles shows their magnetic field. Okay or not? Okay. What will you see here? This is a wire. So around it concentric circle is formed or not? Different. So we can say that these are moving away from it. So we can say these are the perpendicular to the electric field. Means magnetic field and electric field both are perpendicular to each other. Okay or not? When we will pass electricity, so this electrical field will create their magnet, or this magnet it will perpendicular to the magnetic field. Okay or not? Okay. So we can say there, so this is the simple included point here, that when we will pass electricity through the wire, so this electricity arrange all iron fillings in the form of concentric circles, or around the wire magnetic field are in the form of concentric circles, or this concentric circle started from the center point. Okay or not? Okay. The different points we included here, which I am explaining here. Listen. Okay, one thing. Number 1 point we included here related to this experiment, the amount of current flowing. The amount of current flowing through a conductor. Through a conductor. Previous time I told you, more value of current, more will be the magnetic field, and more will be the magnetic field, more will be the concentric circle. So we can say there, this is a cardboard. If you will pass wire through it, so simply iron fillings around it. If you will increase the current value, so you will get more and more concentric circle around it. Okay or not? Okay. So we can say this electric behavior will create magnetic field, or this magnetic field will depends on the current value. So we can say we will denote here magnetic field by B. It is directly proportional to I, means current. More current, more will be the magnetic field, more will be the magnetic field, more arrangement iron fillings in the form of circle, or more circle, more magnetic lines, or more magnetic lines means strongest magnetic field. Okay or not? Okay. Second point also we can include magnetic field inversely proportional to the distance. We can say simply around it all iron fillings arrange themselves in the form of circle properly. But when you will move far away from this wire, so what will you see? So this arrangement is not properly. So we can say there magnetic field value is going to decrease when we will cover distance from this wire. When we will move away from this wire. So we can say that magnetic field is strongest when we will be near to the wire. Okay or not? Okay, means it arranged iron fillings in proper lines, circles. Okay, when you will move away from the wire, so this magnetic field line totally disturbed. Okay, so these lines will not arrange themselves in a proper direction. Okay or not? Okay, so we can include when we will move away from the this wire, when we will move away from this wire, so magnetic field lines strength will decrease. Okay or not? Okay, so these 2 points we have to include: more current, more magnetic field. Clear? More distance, less magnetic field. Less magnetic field. Okay or not? Okay, you can use a simple example also. If you have natural magnet, what a natural magnet, simply one thing, listen, you have natural magnet, the range of this magnet up to here, and you are keeping this magnet here, it will attract it? No chance. And when you will keep it, this iron on this line, it will apply, this magnet will apply little bit force on this iron piece. Okay, when you will put here, you can understand their force value will increase, and you will keep it automatically attracted towards, you will not be able to stop it, this iron piece. So we can say that when you will move near to the magnet, the strength of the magnet will increase, and when you will move away from the magnet, so simply you can say the strength of the magnetic field will decrease. Same thing you can include in the case of this wire electric current. Okay, when you will pass electricity through this wire, more electricity, more current, so we can see the arrangement of the iron fillings in the form of circle more and more. It's clear? If you will increase when you will move away a little bit from this wire, so you will see that the arrangement into the iron fillings is not proper in the form of, means they cannot be able arrange themselves in the form of circles. Okay, so these things we can include in the case of what? In the case of concentric circles. Okay, if more concentric circle, so we can say there more magnetic field, so more attraction will be there. Okay, if a less concentric circle, so this can be the part of your many applications. So next time I will discuss you by magnetic field we can create electricity, or by electric field we can create this time I am discussing with you all by electric field, by electricity. By electricity we can create a magnetic field. By electricity we can create magnetic field. This part is very important. Electric field I am including here, but electric field means electricity. Okay or not? Okay, so simply we can say that when you will create electricity, will pass electricity through the wire, so this wire will behave like a magnetic field. Okay, this is the simple explanation. Later I will tell you the direction of all these concentric circles. Okay.